Hi, welcome to my kitchen / chemistry lab for the day. In this video, we are going to be using my chemistry lab book to do the law of conservation lab. And I really love this lab because it not only shows us how the law of conservation works, but it also proves to us why our reactions need to be balanced whenever we write a full-on chemical reaction. So the idea of the law of conservation is that anytime a chemical reaction takes place, the amount of matter is going to be conserved. So whatever amount of reactants there are in grams, its mass, you should get that same amount on the back end of the reaction as product. So the lab itself includes 3 different small chemical reactions that you could do. I'm going to do only 2 of them. And this is going to be a lot of fun. So make sure that if you do this lab alongside me, you are very careful. It's all food grade ingredients that we're going to be using, so it should be very safe, but make sure that you are never labbing alone. I am a professional, but you should be labbing with a friend or a parent or a lab partner. All right, the very first reaction we are going to do is the reaction that takes place inside of a glow stick. Now, I just picked this up at my dollar store. I actually keep these in my emergency preparedness box. They work pretty well for any power outages. So I'm just using one of those, and I'm going to set up my balance here. I'm just using this beaker to hold the glow stick. Okay, so this balance has a reading of 0.1112, and that is going to be, I'm not in grams, I'm in pounds. That is first off. So let's change this to grams. Okay, so I'm at 50.43 grams, and if I hit this button that says tare, T-A-R-E, that is going to, I may have to press it again because I was leaning on the counter. Let's see. It's going to zero out my balance. So now my balance says 0.00. And I'm going to take the mass of this glow stick, and I'm getting 12.43 grams. Now this is the reactants inside of this glow stick. Next time you get a glow stick, you should check it out. I don't know if you can see, but there's like a tube inside of this bigger tube. The outer tube has the pink fluid, and then inside that inner tube, that's what's going to crack, and it's going to release a second chemical. And when I crack the tube, the 2 chemicals are going to come in contact, and that's their chemical reaction. So I'm going to do that right now. I have cracked the glow stick. My chemicals are mixing now. Nope, no more cracking. Okay, so I'm going to shake it to make sure that all of my reactants come in contact with each other. We're kind of struggling at this end right here. Oh, is it going? Okay, this looks pretty good. I can tell that it's glowing. Perhaps you can't because the light is so bright in here. Again, I'm going to tare my balance just because sometimes things shift around. Also, the camera here could be having some interference. You can find that with phones sometimes too. So I'm going to take the mass of this thing again, and we're coming in at 12.44. This might be picking up a tiny bit of oils from my skin. If you wanted to do this totally perfectly, you would handle the glow stick with gloves on so that your skin oils don't get stuck to the glow stick. And I'm gonna come back to this in a few minutes. We're gonna do our second reaction and then come back to this at the end to make sure that we are conserving mass. I'm gonna use this little thing called a weigh boat. And again, I'm gonna tare right here. And my goal is to get 25 grams of baking soda or sodium bicarbonate. I'm using this scooping tool, often called a scoopula, to get into my baking soda, and I'm trying to measure out 25 grams here. Wowzers, this is coming up. Should be a lot more than I thought it was. 21, 24.92, 25.03. That is perfectly okay. It does not have to come out to exactly 25. If scientists did that, science would never get done. So this right here is 25.03 grams of sodium bicarbonate. And then here I have 50 milliliters of vinegar, but I want to get 25 grams of it into this balloon. So I'm going to measure this and then pour it into the balloon, kind of making a water balloon. But really what's going to happen is I'm going to put the baking soda in here. I'm going to put the vinegar in this balloon, secure the balloon to the top, and then pour the vinegar in, and then the two components will be here mixing. So because this is my reaction vessel, the two of these together, I have to find their mass as well, because when I take the final mass, this is going to be included. So I'm going to tare this whole thing, and we're going to take the mass of, we can just do both of these together, that is quite all right. And we're getting 94.17. I should be writing this down. So our reaction vessel is 94.17, and our baking soda was 25.03. This is all in grams. And then I just need the mass of the 25-ish grams of vinegar to put into my reaction vessel. Now, the best way to figure out the mass of a liquid is actually to measure it in milliliters and then do a density calculation. Because this is very difficult to get exactly 25. But this will work for anybody who's just trying to test the law of conservation. If we go over, which we likely will, we don't want to go over by too much. We don't want to go under by too little. Like right now we're at 24 even. I only need 1 more gram. So I'm actually going to use this pipette to finish us off. Oop, 25.10. Okay. So now here we go. We are going to build the reaction vessel. Vinegar was 25.10. So in total, we should come out to 0, carry the 1, 1, 2, 3, 4, carry the 1, 10, 11, 12, 13, 14. Okay, so in total, everything that we're putting into the reaction comes out to 144.30 grams. That's what I have collected here. So we're gonna run this. So we're gonna set this aside, and we are going to very carefully, with the weigh boat kind of bent a little bit, pour this into the reaction vessel, which in this case is an Erlenmeyer Flask. If you have a funnel would help quite a bit. We don't have a funnel. We have like a little bit of powder left over in here, and that's going to happen with the weigh boats just because sometimes they get a little staticky, especially in the winter. If the air is a little dry, that looks pretty good. But that's something that we can say in our error calculation, that we had a tiny amount of baking soda left in the weigh boat, which is going to explain the tiniest little discrepancies. Now I have my balloon, and I'm going to do my best to get this vinegar inside of this balloon. Now sometimes it helps to kind of like stretch this out a little bit. You should never try to inflate this with your mouth, because this is now a lab material, and you should not put your mouth on lab materials. But I used to have a balloon inflator, like one of the pump inflators, and that would be great for kind of stretching this balloon a little bit. So we'll see if we can pour this. A little pinch on this can kind of, see it's an oval. If you pinch the ends of the oval, you can turn it into a circle a little bit. That's what my strategy is here. The goal is to pour very slowly, and this is working. If you are labbing with a partner, it would be good for them to kind of hold the bottom of the balloon just in case you drop it, like hold it down here. So I have my vinegar inside this balloon now, and I'm going to try to stretch the mouth of this over the Erlenmeyer flask. That's why it's a good idea to have the smallest flask that you can. I don't want the vinegar to spill in just yet, but now you see I have this like water balloon here. That's what we're going for. And I am going to flip this in. We could also remeasure the mass if we like from this point. My balance is tiered, reading at all the zeros, and this is 144.20. So it appears that we lost, between our pourings, only 1/10 of a gram of mass, which is pretty good. Okay, ready, set, go. I'm just gonna hold this on here so that it doesn't fly off, because that can happen. Notice that all of the gas that is being formed here is inflating my balloon. Now we can give this a little swirl because it's very apparent that there's some baking soda stuck on the bottom here. So I'm going to swirl this a bit. Make sure all of my reactants are reacting. Now, if there's anything left over, that's technically called a limiting reactant or a limiting reagent. Well, not the thing that's left over. The thing that gets used up is what limits the reaction from continuing. So if you think of it like cooking, it's kind of like trying to make peanut butter and jelly sandwiches, but you're all out of bread. So you are stunted. You can't make any more sandwiches. That's kind of what's happening here. So what I'm going to do now is remeasure this reaction vessel to make sure that we haven't lost any mass. And according to the law of conservation, really all of it should be here. So my balance is tiered, reading 0, 0. And let's see what happens. Oh, wow. Okay, we actually came back at the finale with 143.65. That's kind of interesting. My guess would be it's because this balloon is a gas, like it's full of gas. So this gas is trying to lift up and it's not really putting pressure on the balance. So based on that, we lost a little bit of mass, but I would say all in all, the reaction went well, and we maintained most of the mass in this reaction. The last thing we need to do here is just measure the final mass of the glow stick. And I like this one a little bit better because none of the products are a gas, which is probably a better indicator than this balloon where the gas is like lifting off the balance. So we are going to go back to this beaker. Make sure the balance is tiered, reading 0. And here is that glow stick whose mass comes in at 12.40. 12.44. Which I don't remember if that data is good or not, because I didn't write it down. So I guess I'll just roll the tape and find out if this thing has maintained its mass. Something that I would comment on as a source of error here, again, is the oils from my fingers being on the balance, or on the glow stick rather. And now we're reading 12.44. Okay, it's kind of bouncing back and forth a little bit, which is fine. It happens. But that is it. Those are 2 reactions that you can use to test the law of conservation. Truly, you could test any reaction. The important thing is that if your reaction is going to generate gas, that you find some way to capture that gas, because otherwise it disappears and you can't measure it. not that it's gone, it's just that you missed the opportunity to measure it. So that is the law of conservation. I hope that you have enjoyed this. Please let me know what chemical reactions you chose to do in the comment section below the video. Subscribe so you don't miss my next lesson or lab, and I'll see you there. Bye.